In early October 2025, when the interstellar object 3IR Atlas passed by Mars, two European spacecraft were just 30 million kilometers away, marking the closest observation for any European Space Agency mission. None of the probes were designed for such purposes, but now they had to capture something barely discernible, distant, and moving quickly. The task was challenging, but when the color and stereo imaging system known as CASIS aboard the ExoMars Trace Gas Orbiter began capturing images, something astonishing appeared on the screen. In the center of the frame appeared a barely noticeable white dot, slowly descending. This dot was the three-eyed Atlas. What we see is not the solid core of the comet, but its coma. A misty cloud of gas and dust surrounding the core as it heats up near the sun. The core itself is probably only a few kilometers in diameter, too small to be resolved. Nevertheless, the coma stretching for thousands of kilometers was clearly visible. It softly glowed against the backdrop of space, confirming that the sun's warmth awakens the comet from a long interstellar slumber. When the frozen gases evaporate, they carry dust clouds outside, forming this glowing cloud. However, the full dimensions of the coma cannot yet be measured. Its brightness quickly decreases as it moves away from the core, fading against the background noise of the image. And although most comets develop a long tail that can stretch for millions of kilometers, here the tail is not visible, at least not at this moment. CASIS's data suggests that the tail of Comet Atlas is still too weak, possibly just beginning to form as the comet accelerates toward its perihelion at the end of the month. Nick Thomas, the lead researcher of the CASI camera, explained that the comet is 10,100,000 times dimmer than the usual Martian targets captured by CASIS. The situation was somewhat different on Mars Express. His onboard cameras captured significantly shorter exposures, only half a second each, compared to the 5-minute limit on the ExoMars orbiter. And while 3 Atlas moons did not appear in these frames, the scientists are not willing to give up. They plan to combine several images to enhance the signal, hoping that a faint interstellar glow will manifest once the data is merged. Both orbital spacecraft also attempted something more ambitious, to measure the light spectrum from the comet. However, it is still unclear whether the object was bright enough for these instruments to capture significant spectra, but the analysis continues. In the coming weeks, scientists will continue to process and compile data, searching for any clues about what the 3 moons of Atlas are really made of and how they behave under solar radiation. Meanwhile, on October 4th, 2025, one of Perseverance's navigation cameras quietly captured something unusual. A thin glowing line slicing through the darkness of the Martian sky. However, NASA's NavCam is not designed for astronomical observations. This workhorse among cameras helps the rover manage movement and plan routes. But that night, while scanning the Martian sky over the Jezero crater, its lens captured undeniable evidence of the interstellar comet 3I Atlas passing at a cosmic distance from Mars. This image is now featured as Photo of the Week on NASA's website. It looks long and symmetrical, as if specially designed. But is it really so? The rover's camera is designed to see fine details up close, but when it looks at something distant, like the 3 moons of Atlas, nearly 38 million kilometers from Mars during a flyby, each pixel suddenly encompasses a vast area, about 12,000 kilometers wide. In this photo, a bright stripe appears to be 4 times longer than it is wide. If counted, this makes its length nearly 50,000 kilometers, which far exceeds the possible dimensions of an object. And this is where the problem begins. Previously conducted measurements of the Sphere X mission set an upper limit on the true size of the object at 46 kilometers, suggesting it reflects about 4% of the sunlight that hits it. Thus, the stripe in the image on the NavCam turns out to be about 1,000 times longer than the actual object. If the 3-eyed Atlas were truly a cylinder 50,000 kilometers long, it would appear enormous in images from the Hubble telescope taken in July 2025, occupying about 23 arc seconds. But in reality, Hubble saw nothing like it. He looked like a tiny, indiscernible point of light. This means the stripe could not be a physical structure. It must have been a photographic artifact. And the best explanation? Motion blur. To capture something as faint as an interstellar object from the surface of Mars, the Perseverance imaging team had to overlay hundreds of short exposures over several minutes. During this time, the Atlas trio noticeably shifted against the backdrop of stars. And although such images could spark a storm of emotions on social media, the best photo of the 3I Atlas from the Mastcam Perseverance camera was processed by one of the accounts on Twitter. The link is in the description. Meanwhile, several orbital spacecraft circling Mars, including the Martian Reconnaissance Orbiter, were directed to the same patch of sky that night. For a brief period, the Atlas IIIs became one of the most closely observed interstellar visitors, captured simultaneously from orbit and the surface of another planet. However, the image that could ultimately resolve the question of its size did not come from Perseverance. It will be obtained using a high-resolution camera mounted on a Martian Reconnaissance Orbiter, which achieved a resolution of about 30 kilometers per pixel during observations on October 3rd. This is more than 400 times more accurate than NavCam. Ironically, many NASA sites and feeds have frozen, affected by the government shutdown just when we need timely updates. The closure of key public access during interstellar flights seems extremely convenient, especially as researchers around the world strive to monitor what could be the most unusual object ever seen in our solar system. Speculation has already reached a high level. Some speculate that it could be a very active comet, unlike any previously observed. Others propose more exotic ideas: a probe from beyond the stars, a piece of technology, or an alien spacecraft. Regardless of how plausible these theories are, the timing of the access closure raises questions. Fortunately, we may have an ally. On October 2nd, the Perseverance rover captured a streak in a series of images taken over a few minutes. This streak does not match the usual movement of the Martian sky's background. Instead of being vertical or aligned with the star trails caused by Mars's rotation, this path is tilted and unchanged in all images. It is a real object, not a glitch, and it moves quickly. It can be assumed that what we saw is the 13th object, known as the 3I Atlas. Drew, whose Twitter post prompted further analysis, noticed this stripe. The size of the object remains a mystery, but the minimum estimates hover around 5 kilometers in width, possibly more. It lacks the huge classical tail of a comet. Instead, it seems to be hidden behind an extensive blur of a coma made of ionized gas and dust. Its speed is astonishing, about 60 kilometers per second, accelerating to a maximum of around 68 kilometers per second as it approaches perihelion at the end of October. Around the 25th of September, a coronal mass ejection struck the 3I Atlas. It could ionize or activate its surroundings. However, subsequent images taken on September 27th and October 2nd showed no catastrophic changes, no sharp breaks in the tail or fragmentation, only hints of a gradual expansion of its shell. That's why the lighting from NASA was so important for everyone. The upcoming JUICE mission will intercept an object as it continues its journey to perihelion. However, the connection between Earth and the Sun will delay most of the data transmission. In total, these resources could create a more complete picture of the 3I Atlas. Currently, the mystery of the stripe has nothing to do with alien engineering, and it is far from the scales that some speak of. But what is the size of the 3I Atlas? Determining the true size of a comet can be difficult. The challenge lies in separating the nucleus from the haze of the coma around it. As the comet approaches the Sun, its frozen ice turns to gas, carrying streams of dust into space, forming its characteristic tail or coma. This could make the comet significantly larger and brighter than the solid body itself. Now, a team from Harvard, led by Richard Clutie, Avi Loeb, and Peter Varesh, has analyzed observations from the 3I Atlas, collected from May 15th to September 23rd, from 227 different observatories around the world through the Minor Planet Center. They compared the actual trajectory with what we would expect if only gravity were acting. The scientists discovered a small but noticeable push, amounting to less than 15 meters a day per square meter. However, comets with active gas emissions usually receive a slight push from the jets of escaping gas. In the case of the comet 3I Atlas, the measured non-gravitational acceleration turns out to be surprisingly low compared to the observed gas emission. This indicates that the comet's core is heavy enough to resist the strong impact of these jets. Researchers estimate the mass of the comet's core to be over 33 billion tons, with a diameter of about 5 kilometers, excluding the surrounding cometary gas. This makes her about 3 to 5 orders of magnitude more massive than the previous interstellar visitors. Loeb argues that, given the expected number of such objects and the content of heavy elements in interstellar space, we should have seen many more modest-sized interstellar objects before encountering such a massive one. However, this did not happen, and it highlights 3I Atlas as a significant exception. Loeb even considers a speculative alternative that this object may be of technological origin, pointing to its unexpectedly large mass trajectory alignment, and some supposed detections of nickel without iron as provocative clues. Nevertheless, NASA scientists urge caution. The prevailing opinion remains that it is most likely a natural object. Meanwhile, some scientists do not question what Tri-I Atlas is, but what it could mean. Astrophysicist Susanna Falsner's idea is simple, yet impressive. 3. II Atlas may be the seed for forming a planet, but how can a wandering stone from another star system initiate the birth of an entire planet? Let's take a look. We enter a young solar system where a new star is at the center of a large, dusty ring. Here, tiny grains of stones merge like smoke, forming pebbles. Over time, they accumulate into boulders, and then into planetary prototypes, raw components of planets. Given enough time, they grow large enough to gather even more material. This sounds simple, but as we will see, there is a serious problem in this picture. Disks exist for only a few million years before gas is swept away. This time frame seems too short to explain how massive planets like Jupiter and Saturn formed. Now let's imagine another situation. An interstellar object falls into this disk, a body already large enough to serve as a ready core. Instead of starting with dusty particles, the disk suddenly receives a solid seed that can immediately begin attracting surrounding gas and materials. Thus, an alien traveler can accelerate the birth of a new planet. Falsner's simulations confirm this idea. She found that massive stars capture interstellar objects better than smaller ones. Indeed, gas giants are more common around larger stars. The coincidence of theory and observations is striking. If so, interstellar objects like Oumuamua, Borisov, and Atlas are not just wanderers. They may be sparks igniting planetary systems. Some of them could have been gas giants in distant systems. Others may have played a role in the early history of our solar system. This is a bold idea, and it remains unproven, like some other theories. Interstellar objects are notoriously difficult to study. They appear suddenly, move quickly, and vanish into darkness. But this time, we were ahead of events, as we managed to detect him in advance, and our technology may finally allow us to reveal his true nature rather than just guess about it after his disappearance.